Hello, my name is Yijun Ding. Today, I'm going to talk about my project 2 for IA697B. My project is on exploring using Pluto and Julia for STEM teaching. Julia is a new programming language. As this article on Nature has pointed out, Julia is gaining speed in the scientific community. And this is because Julia as a scripting language, which is similar to MATLAB and Python, is easy to understand. But unlike MATLAB and Python, or even better than MATLAB and Python, Julia is fast for complex computations. And Pluto is an interactive environment for Julia. I got interested in Julia and Pluto because I started watching this YouTube lecture from MIT on computational thinking. And they were using Julia and Pluto for teaching computational courses. So how do we get to Julia? Here I will briefly show you how to start Julia and how to use Pluto. So this is Julia. Julia is like a little computer. You can enter 1 + 1, and Julia will tell you the results is 2. You can also enter 2 multiplied by 5. Julia will tell you it's 10. But other than a simple calculator, Julia can do a lot more than that. And we will use Pluto to do that. Type in using Pluto, and then type in pluto.run. Now this will start Pluto on the browser. This is the starting page of Pluto. From here, you can open sample notebooks or create new notebooks or open the notebooks you already have. Here is a Pluto notebook that I have designed to demonstrate how to use Julia and Pluto to teach optics. So this shows you that Julia and Pluto can be used to generate web page-like content. However, Julia and Pluto can be used to generate a lot more complex material. For example, you can provide interactive instructions like this. In this section, I want to know what the student's background knowledge level is. So I asked the student a question. Are you familiar with the concept of focal length? If the student select yes, then they will get a response and continue reading to the next concept. If they select no, then I give them a hint. I would like the student to learn how to calculate the focal length based on a given shape of a lens by using the lens maker's equation. If the student feel confused and they would like to watch a video to explain how the lens maker's equation is defined and how to derive the lens maker's equation, they can click here and it will reveal a YouTube video to explain the lens maker's equation. After the student have understand the lens maker's equation, I would like the student to understand it better by playing with this interactive data visualization section, where the student can use the slider to choose radius for the first surface and the radius for the second surface, and see how the focal length changes with both radius. If we keep radius 2 at a fixed value and changes radius 1, then the student would notice as the radius 1 increases, the focal length also increases. And this same trend can also be observed with a plot, which is this next section, plotting to visualize data. And in this plot, I'm trying to show the relationship between the focal length and radius 1. And the previous trend that we have observed can be easily seen here. As radius 1 increases, we see the focal length also increases. And the goal here is to use those interactivity for the student to better understand the lens maker's equation. In this notebook, we have demonstrated using Julia and Pluto to teach optics. We explored using Julia and Pluto to prepare a web page-like content, to provide interactive guidance, and to visualize data and the equation.